To find all of the horizontal asymptotes of this function, we need to first look at the limit as x approaches infinity of our function, and then look at the limit as x approaches negative infinity of our function. So, as x approaches infinity, as the x values get increasingly larger, the plus 2 in the numerator and the plus 3 in the denominator become insignificant, and we can eliminate those. The square root of 9x squared is equal to the absolute value of 3x, and 4x is just 4x. So what we have to then think about is what happens when we take the absolute value of 3 times infinity. Well, 3 times infinity is a positive number, and so the absolute value of a positive number is just that original number. So this limit is equal to the limit as x approaches infinity of 3x over 4x, and we can cancel the x's to get the limit as x approaches infinity of 3/4, which is just 3/4. So this has a horizontal asymptote of y equals 3/4 to the right. Now we have to investigate what happens as we find the limit as x approaches negative infinity. So the first step is going to be the same. We'll eliminate the plus 2 because it's insignificant, and we'll eliminate the plus 3 because it's insignificant, and we'll end up with the limit as x approaches negative infinity, once again, of the absolute value of 3x over 4x. Well, 3 times negative infinity is a negative number, and so when you take the absolute value of a negative number, you end up getting the opposite of what's inside the absolute value sign. So this now becomes the limit as x approaches negative infinity of the opposite of 3x over 4x. Once again, the x's will cancel, and you've got the limit as x approaches negative infinity of negative 3/4, which is just negative 3/4. So this has a horizontal asymptote of y equals negative 3/4 to the left. This is a common question that you might see on the AP test, where it has different horizontal asymptotes in opposite directions. For this next one, we're going to look at the limit as x approaches infinity of an exponential function, e to the 6 minus 2x plus 5x squared. So the first thing we want to do is say, what happens to 6 minus 2x plus 5x squared as x goes to infinity? Well, as x goes towards infinity, the 5x squared dominates the 6 and the negative 2x. So they become insignificant, and this just becomes e, or the limit as x approaches infinity, of e to the 5x squared. Which, if we plug in infinity, just gives us e to the infinity, or just infinity. Over here, the 2 is insignificant as we go towards negative infinity. The x cubed dominates. So this becomes e to the negative infinity cubed. Negative infinity cubed is still negative infinity. So e to the negative infinity is 1 over e to the infinity using exponent rules, which is 0. We can, in this problem, substitute out the 4x squared plus 5x minus 2 as a u, and then think about what happens to u as x approaches infinity. So as x approaches infinity, u is approaching 4 times infinity squared, which is infinity, plus some more insignificant infinity minus some 2. So we end up with, as x approaches infinity, u is also approaching infinity. So this limit is effectively the limit as u approaches infinity of the natural log of u. And we know what the natural log graph looks like. It looks something like that. And as the values go towards infinity, the natural log function continues to increase without bound and the answer to this limit is infinity. We'll use a similar process on this one. We were going to look at u equaling 1 over x to the 4th minus 8x. And as x approaches negative infinity, u begins to approach negative infinity to the 4th, which is dominating the negative 8x here, and negative infinity to the 4th is positive infinity. So this begins to approach 1 over positive infinity, or 0 from the positive side. So we can convert this limit into the limit as u approaches 0 from the right of the natural log of u. And once again, if we think about the graph of natural log, as we approach 0 from the right-hand side, our function is going down towards negative infinity. So this limit is negative infinity.